This presentation is one of a series dealing with cargo operations on board an oil tanker. Here we will deal with cleaning and gas freeing of the cargo tanks and lines. After discharging the cargo, our vessel is scheduled to dry dock, prior to which the ship has to be cleaned to a gas-free condition. Currently, the weather is fair with a moderate sea. The vessel is in a light ballast condition and trimmed heavily by the stern. Should the weather turn worse, it may become necessary to take on board more ballast water. Our vessel has 7 cargo tanks and 2 slop tanks. Port and starboard slop tanks are filled with ballast to almost 6 meters ullage. The vessel carries ballast in 5 segregated ballast tanks. There is no double bottom. Filling the slop tanks with water is actually the first part of the tank cleaning. While you do this, you can also clean all your cargo pumps, deck lines and the manifold pipes. Let each pump take water from the sea. Circulate it through the manifold, back to the pump room and the port slop tank through the marpole line. Next, circulate water through the drop lines, back to the crossovers in the pump room and to the slop tanks. The ship is trimmed by the stern as much as possible. You're ready to start cleaning the cargo tanks. The crew has been informed of the procedures and the different restrictions imposed due to the cleaning of the tanks. Before you start the operation, check that all tanks are properly inerted, which means that the oxygen content in each tank must be lower than 8%. Measuring the oxygen content, you find it okay. There is an average oxygen content of 3 to 4% in the tanks, so it's safe to start cleaning the vessel. At the time, there is a team busy testing the heating coils. This is very important. Just a few litres of oil leaking from a coil into a tank can cost a lot of money, as the ship will no longer be gas-free. No shipyard will hesitate to charge heavy cleaning costs if this is discovered too late. In our vessel, the coils are kept full of fresh water when they're not used, making it easier to check them for leaks. Checking is done by first pressurizing the main steam line with air. The drain cock at the return side of the coil is opened. Now open the inlet valve, and if there is no problem, clean water should come flowing through the drain cock quite quickly. If there is no water in a coil, this indicates a problem, most likely a leaking coil. Coils containing oil must be properly flushed with water to remove all oil. In our vessel, to clean the cargo tanks, there are 32 permanently mounted cleaning units. Usually they're called guns. There are 4 in each centre tank. There are also 2 deck-mounted guns in each slop tank, as well as 2 guns permanently mounted in the bottom of each slop tank. There is also the possibility of using portable tank cleaning equipment in each tank. A unit consists of the gun unit and the power unit. At the lower end, there is a revolving nozzle which can be directed at most surfaces within the tank. The movement, a horizontal rotation and slow elevation change, makes the single jet of water or oil move in a helical pattern. The movement is governed by a turbine driven by the liquid used for washing. Water or oil is pumped through the guns at high pressure. Normal working pressure on this vessel is 8 to 10 kilograms per square centimetre. It is the revolving jet inside which cleans the bulkheads and tank bottoms. With this type of gun, the speed of rotation depends on the pressure. At a pressure of 10 kilograms per square centimetre, the speed is approximately 2 revolutions per minute. Elevation range is from 0 degrees to 150 degrees. The power unit contains a mechanism which enables you to choose from 4 different grades of cleaning. You only have to turn the programming knob to the desired program between 1 and full. By doing this, you alter the change in the nozzle's elevation per full revolution. This change in angle is called the pitch angle. The smaller the pitch angle you choose, the more effective the cleaning you get, but the longer it takes. Here, the programmed presettings of pitch angle are 1, 2, 3 and 8.5 degrees. Left alone, the gun will sweep and clean between 0 degrees and 150 degrees. But by using a special hand crank, you can move the nozzle to start from any position within this arc. Idle guns are usually docked in the 0 degree position. Since we have only one eductor, we plan to wash one tank at a time. First, wash the bulkheads. They're relatively easy to clean, as a thorough crude oil wash of the tanks was made during discharge, so a 1-hour wash will probably be sufficient. The guns need to be set up so the water jets will pass the bulkheads twice, from 30 degrees to 150 degrees and back down to 30 degrees again. So before starting, the nozzles are taken up to 30 degrees using the hand crank. The programming knob is set to Program 2. As normal operating speed of the nozzles is 2 revolutions per minute, with Program 2 selected, the nozzle will elevate 4 degrees in 1 minute. 240 degrees will be covered in about 60 minutes. Cleaning the bottoms of the tanks is more difficult, as the structure is more complicated. Since a thorough crude oil wash was done during the discharge, and considering the quality of previous cargo, wash the bottoms for only 2 hours. If in doubt, a longer wash may be necessary, perhaps 3 hours. This time the guns are set to Program 1, when they come down to approximately 30 degrees, so the pitch angle is reduced to 1 degree per full turn. As the speed of the nozzle is the same, you will now cover 2 degrees in a minute, and therefore 60 degrees in 30 minutes. Washing for 2 hours will sweep the bottom 4 times. Since you don't want to wash the bulkheads again, you have to make the nozzles turn back down at 30 degrees on their way up. Use the hand crank. There is no other way than cranking the nozzle all the way up to 150 degrees and down to 30 degrees again. Turn off the water before you crank the guns and keep track of what you're doing. During tank cleaning, it is ballast from the slop tanks that is used as cleaning water. You must work with a completely closed system, recirculating the used washing water so that oil is not pumped into the sea. To minimize the risk of overflow, don't forget to set the slop tank high-level alarm to 3 to 4 meters. This will give you time to react when necessary. Strip the tanks with the eductor. The eductor on board this vessel has a capacity of 800 cubic meters per hour, which is more than enough to strip the water from 4 guns working at pressures of 10 kilograms per square centimeter. Each gun gives 100 cubic meters per hour. Remember, using the eductor, you can just wash 1 tank at a time. Start cleaning cargo tank number 1, stripping through line number 1. You can take cleaning water with any of the cargo pumps, as they can all be connected to the tank wash line. Here you feed the tank wash line with pump number 3 from the starboard slop tank. The same pump is feeding the eductor. The pressure on the wash line should be about 10 kilograms per square centimeter. One of the main suctions in the center line of cargo tank number 1 is opened. The port slop tank is now filling. Keep an eye on the level of this tank. There is a U-pipe connecting the port slop tank with the starboard slop tank. When this U-pipe is open, the water starts to flow back to the starboard slop tank when the ullage in the port slop tank is less than 10 metres. The oil returning with the dirty water from cargo tank number 1 flows to the top of the port slop. Relatively clean water now flows from the bottom of the tank back into the starboard slop. This way the washing water is circulating in a closed system. This is an eductor. Not exactly the same as on our ship, but the principle is the same. There are no moving parts. When the driving liquid is forced through the nozzle, an underpressure is created, and the eductor will suck as long as the pressure of the driving liquid is sufficient. You're now bottom washing the tank. After every full cycle, you have to close off the water and hand crank the nozzle all the way up and down again to 30 degrees. The number 1 rule when bottom washing is to keep the bottom free from water. If you can't keep the bottoms relatively dry, you will have problems cleaning the tank. You have to dip the aft end of the tank regularly to detect eventual build-ups of water. Stop the bottom washing for a short time while doing this. If water should build up, you will have to stop 1 or 2 guns while draining the tank. And of course, you must try to find out why the eductor isn't taking care of 4 guns. Is this tank clean? Have I cleaned the tank enough? These, of course, are the crucial questions. With the tanks inerted, you cannot see what the tank is like at the bottom. Only experience can guide you. In some ships, it's possible to take samples of the returning water at the pumps. Before you finish with the tank, it might be a good idea to wash it with clean water from the sea for a short time. If the return water is clean, you can be pretty sure the tank is clean. When you're satisfied that the tank is clean, prepare to purge and gas-free cargo tank number 1 as soon as possible while you're cleaning the other tanks. Start washing in cargo tank number 2 using the same procedure. The tank is stripped through line number 2. You have to purge a cleaned tank to avoid getting into a situation where the vessel is no longer inert. This means that you must ventilate the tank with inert gas to get rid of the hydrocarbons from the mixture of gas left in the tank. No hydrocarbons means no risk of creating an explosive environment when oxygen is later added during ventilation with fresh air. The inert gas valves should be closed to the tanks not being purged. Check oxygen levels in the tank you're cleaning. The Butterworth hatches in the aft part of cargo tank number 1 are opened, and the inert gas is allowed to pass through the tank. There is great turbulence in the tank. Watch the pressure at the IG system. Keep a pressure of 200 to 400 millimeters. Otherwise, there is a risk that the IG fan will overheat. As a rule of thumb, you can say that to purge a tank, you have to change the atmosphere 3.5 times to get rid of the hydrocarbons. Our IG system has a capacity of 15,000 cubic meters per hour. The volume of the tank is 17,293 cubic meters, so it will take you something like 4 hours to purge the tank. There is now a lot of gas streaming out on deck. Keep people working on deck away from it. If necessary, steer a more favourable course. As a matter of discussion, it is also possible to purge tanks through the bottom lines in this ship. This is a matter of company policy. It is our experience that this method cuts costs when already gas-free tanks are inerted again. When doing this, you should try to inert half the number of the vessel's tanks at the same time. In our vessel, purging the tanks should be done over deck after the cleaning. Other ships may be designed for different methods of purging and inerting. The tanks are tested with an explosimeter to measure gas. When the content is less than 2%, feel safe to ventilate the tank with fresh air. Introducing oxygen into the tank can no longer create an explosive environment. This graph shows that it is necessary to purge with inert gas before venting. At 11